Here's a segment with endpoints A and B, so we'll label the segment AB. We can measure the length of the segment with a ruler. We put it up there on one of the endpoints, and we look out towards the other endpoint, and we're estimating 11 centimeters. And then we notice it has another scale in inches, and we get about 4¼ inches. One of these measurements, or both of them, are probably not quite exact because I used one of those unit converters, and I discovered that 11 centimeters is closer to 4⅓ inches rather than 4¼ inches. But we'll live with these measurements. And then we can write AB is equal to 11 centimeters and AB is equal to 4.25 inches. And notice we've removed the bar from the top of the label. When you remove the bar from the label of a segment, that means you're just talking about the length or the measure of the segment. So the AB with a bar over it refers to the segment itself. The AB without the bar refers to the length of the segment. Here's an angle. Angle ABC, or we could just call it angle B. We measure angles with one of these, a protractor. And a protractor has two scales. Look at the one on the inside, starting with 0 on the right. Look at the scale on the outside, starting with 0 on the left. We put our protractor down so that the vertex of the angle is at the center of the protractor, and we have to decide which scale to use. And because we've put it down and lined it up with ray BC, we find which scale shows 0 on ray BC. Now we've covered up the 0, but you'll notice the next number we can see on the inner scale is 10, so we need to use the inner scale. And we read up, and we're going to estimate that the number of degrees in this angle is 57 degrees. Now a degree measures the amount of turn. If someone were standing on point B and looking out ray BC towards point C and then turned so that the person was still standing on point B and looking out on ray BA towards point A, the number of degrees represents the amount of the turn. In this case, about 57 degrees. And a way to write that is with this little m, and that sentence is read, the measure of angle B is 57 degrees. We could also measure this angle by putting the protractor like this, and then we would use the outer scale because now we've lined up the other ray. You can start your measurement with either ray. If someone were making the turn by looking from B to A and then turning to look from B to C, the turn would be in the opposite direction. But the number of degrees of the turn, now using the outer scale, would still be 57 degrees. And now let's look at another angle. This angle has the horizontal ray at the bottom pointing in the opposite direction. So we put our protractor down like this, and that means we're going to use the outer scale when we're measuring from the bottom ray up to the one that points up. And from that scale, our value looks to be 109 degrees. We could also turn it like this. You might have to stand on your head to read it, but starting with ray YZ and measuring back to ray YX, we use the inner scale, but we still get 109 degrees. A circle can be divided into 360 degrees as shown by putting two protractors together. A degree then can be divided into 60 minutes. The degrees are so close together, I don't think we can divide the degrees into 60 equal pieces in our protractor. There are tools of measure that allow for degrees to be measured much more precisely. So 1 degree is equal to 60 minutes, and we use the accent mark for minutes. And then if we really want to get precise, 1 minute is divided into 60 seconds, and we use the quotation marks to mean 60 seconds. And that could lead to a measurement like this. We had an earlier measurement of 109 degrees, but if we had more precise tools, perhaps it would be 109 degrees, 23 minutes, and 15 seconds. And then perhaps we would have another angle, 81 degrees, 43 minutes, 34 seconds, and we might want to subtract those two angles, find their difference. Well, when we do that, the first thing is we subtract the seconds. Well, 34 can't be subtracted from 15, so we borrow an entire minute, and we write it like this. The minutes get lowered from 23 to 22 because we borrowed one, and then, since 1 minute is equal to 60 seconds, we convert it to 60 seconds, add it to the 15 seconds, we now have 75 seconds. We do 75, take away 34, and we get 41 seconds. And now we're looking at the minutes. 22 minutes minus 43 minutes. We're going to have to borrow again. This time we borrow an entire degree, and we write it as shown. We borrowed 1, written it up there. A degree is equal to 60 minutes. 60 minutes plus the 22 minutes already there is 82 minutes. 82 minus 43 is 39. And now we have 108 degrees minus 81 degrees. The difference between those two measurements was 27 degrees, 39 minutes, and 41 seconds. What if we added those two measurements? 75 and 34 seconds is 109 seconds. But remember, 60 seconds is equal to a minute. So we take away 60 seconds, bring that over to the minutes column, and that leaves 49 seconds behind. The 60 seconds is equal to 1 minute. So we add that 1 minute to the 23 minutes already there to make 24. Now we have 24 plus 43. And we have 67 minutes. But remember, 60 minutes is equal to a degree. So we carry over 60 minutes, leaving 7 behind. And the 60 minutes is 1 degree added to the 109 degrees, makes 110 degrees. We add that to the 81 degrees. We get a measure of 191 degrees, 7 minutes, and 49 seconds. And while you could make a turn of over 190 degrees, in this series of lessons, when we deal with angles, we will only be dealing with angles 180 degrees or less, and we'll talk about that more later in this lesson. Well, here's two segments that are the same length. And we say that things that are the same size and shape are congruent. So segments that are the same length are congruent. So that symbol in between AB and XY is the symbol that means congruence, and that sentence is read, segment AB is congruent to segment XY. Their lengths are the same, so we can also write that their measures are equal. So the measure of AB is equal to the measure of XY. Labeling a segment with the bar over the top refers to the segment itself. Labeling a segment without the bar refers to the measure of the segment. Segments can be congruent. The measures of segments can be equal. Congruent segments have the same measure. And now let's look at two congruent angles. They also have the same measure. They look the same. They're pointed in opposite directions, but they look the same. So these angles are congruent. We say that angle 1 is congruent to angle 2. And therefore, the measure of angle 1 is equal to the measure of angle 2. Angles can be congruent. The measures of angles can be equal. Congruent angles have the same measure. And now let's classify our angles according to their measures. Angles with measures between 0 and 90 degrees are called acute angles, and there are two examples. Angles with measures of exactly 90 degrees are called right angles, and there are 3 examples. Angles with measures between 90 and 180 degrees are called obtuse angles, and there are 2 examples. And angles with measures of exactly 180 degrees are called straight angles. Straight angles are also lines. So usually, if you're looking at a straight angle, it will most likely be labeled as a line rather than as an angle. And here's something called a parallelogram. And when we make sketches, we don't typically assume that things that look to be the same length are. So when we want people to know that we intended for things to be congruent, or in this case have the same length, we mark them. So the left sides and the right sides have a single tick mark. They're the same length. And the top and the bottom sides have double tick marks. That means that they have the same length. And now in this same figure, there's 2 pairs of angles that are congruent. The upper left and the bottom right are congruent, so they have double arcs. The lower left and the top right are congruent, so they have single arcs. Here's an equilateral triangle. All 3 angles are the same, and they're marked, and that tells us it's an equilateral triangle. Here's the same triangle marked to show the sides. For triangles, if the 3 sides are the same, the 3 angles are the same. So if you mark the 3 sides, that means it's equilateral, or, as we did previously, if you mark the 3 angles, that means it's an equilateral triangle. This figure has 3 sides. 2 of them are marked as congruent, and the third one looks like it might be the same as the other 2, but maybe it's a little shorter. It's not marked, so we can't make any assumptions. We're sure that 2 sides are the same. We're not sure about the third side. Might be the same as the first 2. We're not sure. But now we've marked it. This diagram says that two of them are the same and one of them is not the same as the other two. And the same with two angles. This says that in this triangle, two of the angles are the same. Maybe the third angle is the same. Looks like it might be. Maybe it isn't. But if we mark it like this, what we have shown here is that two angles are meant to be the same, and the third one is different than the other two. So even if the sketch is a little bit in error, and maybe they do look all the same, they're not exactly the same. There are two that are congruent and one that is not congruent with the other two. Segments can be measured with a ruler. Angles can be measured with a protractor. Angles with measures between 0 and 90 degrees are acute angles. Angles with measures exactly 90 degrees are right angles. Angles with measures between 90 degrees and 180 degrees are obtuse angles. And angles with measures exactly 180 degrees are straight angles.